that's really a wonderful, wonderful introduction. Thank you. And I'd like to start by thanking the RCC for this opportunity to be here this fall. I feel very privileged. And also to all of you who have come here today to listen. As all of us, I think, global warming is such an encompassing issue that it's really hard to fathom. And I believe that we might need several venues to sort of enter into this incomprehensible and frightening issue. It's really scary, and the scale is overwhelming. It's complicated and dependent. It's destabilizing. You feel a kind of dizziness and might lose contact with the ground. So I'd like to use the shrinking sea ice that I'm going to talk about as a prism of climate change understanding, trying to work with that metaphor to be able to perspectivize some of my issues. At the core of my interest is sea ice in the Arctic Ocean and the vanishing sea ice, so I actually belong to both the ocean and the extinction theme of the RCC. This ice is cold, brittle, porous, melting slush, but it's also unruly, violent, sharp, and hard. I am actually only remotely, excuse the pun, interested in the ice per se, but I do think that it can, trying to grapple with it is also a way. I'm mostly interested in how we can use this ice, even though I will deal with some of it in this project, how we have understood it and in what ways. You might ask why sea ice. That might be a weird thing to start with. It actually started a long time ago when I was in a project. So in Sweden, we're very often project-based research, and we had a project on Arctic climate change, and it ended up in this is one of the outputs. We got interested in the sea ice minima of the Arctic, and I'm going to show you what those are. So the sea ice really caught my attention several years ago. The sea ice is really important for the global climate, and many of you might know why, but I'm still going to spend some instances on that for those of you who don't. It's a blanket, you could say, in both the Arctic and the Antarctic, and it has a very stabilizing effect on the global climate. However, it is also subject to melting, obviously, and this melting is a problem when temperatures change. So there's something called albedo that many of you might know, but for those of you who don't, it has to do with the reflection of solar radiation, basically. And here, open ice or ocean ice, or even fresh snow-covered ice, has a very high albedo, which means that the reflection is very high, whereas open ocean has a low albedo, which means that it attracts the energy. And this means that when the ice is shrinking, you get a positive feedback loop. I mean, positive not that it's good, but that it works in this way. So the increased warming means that the ice is shrinking, and the albedo then is decreasing, which means increased warming. And this positive feedback loop is bad news for the Arctic sea ice, you could say. There are short-term effects that has to do with the ice in this particular area, of course. I mean, there are regional effects that has to do with resources being able to be extracted, which we are not so happy about these days, at least not in this room, you could say. Fossil gas and oil might be easier to extract. It's also the case that if we have an oil spill in this region, it will take a long time for that area to recover because it's not temperate waters. So it's not like the Gulf of Mexico. There are also long-term consequences, obviously, even though we're not really sure of those, but there are speculations on ocean current effects on the ocean currents. So the ice is important, and it's shrinking. And I'd like to share a few images of this with you as a starting. So this temperature change in the Arctic is actually higher than in the temperate zones. It's called the Arctic amplification, or polar amplification. The Arctic amplification is one of these examples. And here is a map of what the sea ice looked like just a few days ago. This is a polar map. Ron was telling us a bit about Arctic science. Here you can also understand my perspective, that it's, even though there's no up and down and no orientation of the globe and the maps, you can see that we are thinking here of a Western perspective. And I do this partly because of language reasons, right? So the sources I'm accessing are Western and English. But here you can see the extent of the sea ice in 2021, and you have the median from 1981 to 2010 as an orange line. If we look at the minimum, which I am interested in, so the sea ice has an annual variability, which means that it shrinks and grows during the year. And if we look at the minima, this is the trend since the late 1970s. There are many ways of displaying this. You could say that 2021 was good news in a way. We did not go beyond the 2012 minimum, which is the worst we've seen in the last 40 years. Still, though, the last 15 sea ice minima have been the worst. The last 15 years have been also the last 15 worst. So a bit of a pause maybe, but the trend is really rather depressing. All these graphs, by the way, come from open sources. I've used both the National Snow and Ice Data Center, but sometimes I use NASA or European Space Agency, ESA, imagery and data. So, how do we know about these changes? I'm interested in this. Again, I'd like to say that we got some of the answer from Ron. This relies on Cold War technology. So we spoke a bit about the great efforts in science and technology during the 50s and 60s and onwards. So satellite technology really builds on these efforts. This is an IGY. Sputnik was an IGY, International Geophysical Year effort. And not so long after that, the Nimbus meteorological satellites was one of the first US efforts in this vein was launched. After that, we've had an enormous growth in satellite technology for many different purposes. I am mostly interested in this satellite records, even though I will also look into some other kinds of records, as I mentioned very briefly. There are also actually reassessments of old records, and there is release of records from submarines. But my focus is really on the satellite records and the satellite technology that gives us this knowledge. And this is an artist impression. It's a bit of a paradox that the fact that we are finding out so much about our environment also causes space debris. I find that to be right. It's sort of a paradox. But if we just look at another artist impression of some of the remote sensing satellite or Earth surveillance satellites that are around, that this is an image from NASA. Also artist impression, because they don't have these kinds of orbits. You soon realize that there's a lot of data out there. And here, and if any of you are really interested in this, I really suggest that you go into the enormous depositories and the outreach work that these enormous organizations are doing. This is a snapshot, but you can find the real-time visualization of these satellites at the NASA web page so that you can see them, how they circulate. This is clearly catering to both needs of being transparent, but also needs of being able to get new funding. So, I mean, this kind of effort belongs to a larger understanding of climate change science, I would argue. So, let me continue. The basic technology then is that you have the satellite and it encircles the Earth in different ways. For sea ice, it's important to have a polar orbit so that you really can get the information at the poles. Even though there are also, I mean, other ways of accessing this with other satellites. And then just in this is a simplified model, but still, so the satellite then gathers this information in circulating. And they have different kinds of instruments depending on what we're interested in looking at. And this has really also been, there's a big change, obviously, since the very rather passive Sputnik of the 50s, even though Sputnik could also actually relay interesting material in all its simplicity. So, the satellite, they gather a lot of data. And I'm interested then in how this data become imagery. And very often we talk about scenes when it comes to remote sensing imagery. And I here would like to just show an image from Paul Edwards, whom some of you might have read as an historian of technology, but also with great interest in climate change and modeling. Because I think that the cover of Paul's book that came out already 10 years ago now sort of illustrates this kind of the digitized information that then becomes something that we can see and understand. He actually talks about infrastructure globalism because he thinks that there is a techno-scientific network here, a system that's at work. And even though he is focused on a different time period than I am, I think that I rely on some of his thinking in my work as well. He also talks about the technopolitics of altitude, which we might come back to, and which Katie was alluding to. So, what we, let's see, yeah, good. So maybe we can, no we can't. So let's, you can still see that. So the images that the satellite connects, so the information that the satellite gathers is then put into larger images, mosaics. And in this GIF you can see the 3 years of change where the data is very transparent, right? You can see where the data is missing and you can see the SWOTs of the satellite. But more common these days is actually that you don't do that. You smooth out and you fit together into images that are much more, smooth, you could say. And I'd like to take this one as an example. You probably know and recognize this. I think I even saw a version of it in one of the COP meetings. This is done for 20 years ago. It's put together by a visualization expert at NASA, building on about 200 remote sensing images of this part of the globe. But then they're also using other kinds of visual aids to get that idea of the globe that we'd like to recognize, right? So they fit and they smooth out and they adapt. And this is all very transparent, and there's a blog on this particular one that I enjoy reading. There's actually an interesting thing with this particular, and let us get back to that. If you see here, you can identify there is actually a white up on Labrador. There is a cloud that looks a bit strange, right? There's it's like it's cut off. And but here in the sea, I can use this actually. As I said to Max, I wouldn't, but you see that there is a repetition of the clouds, right? That doesn't really work in real life. So there's this cut and paste of cloud imagery that sort of went a bit too fast here. You might recognize this image also because it was actually very common. It's an Access image on Apple devices, and it was the first one who lit up a number of iPhones some years ago. It's really wide circulated. But so my interest is really what happens then if we use this data and we project it onto a sphere like this. Like, so we move from the map image of data to this kind of image. I actually think that, and here you could see the lost sea ice minimum. This is actually from September 16, when we, through this technology, know that this is when it was at its lowest. There's no place on Earth where you can stand as a human being and see this, right? This is totally accessible to us through science and technology, or a techno-scientific knowledge, which goes for a lot of stuff in relation to climate change, obviously. But, so, the planetary then. The sea ice becomes planetary with these visualizations, and you might say that this is then a way this is a kind of environing, I would argue, an environing technology. Helmut was alluding to that last time. So, the planetary is no stranger to an environmental historian, right? But what are the consequences of this? I'm not sure, but at least I'd want to explore the planetary dimensions here. So the blue marble of 2002 was, of course, a blue marble. It had relations to the original blue marble that you might know of, and which is arguably one of the most reproduced photographs of all time. It's called S171482277 from the Apollo 17 mission in 1972, and it was taken by chance. And there are many stories written about this, and also many stories that are scholarly. For example, Dennis Cosgrove or Robert Poole, but also Sheila Yasanow from a different tradition. Robert Poole was an historian, a British historian. He was arguing the conversation that you might know a good place of popular writing by scholars, that we actually should have another one taken now in the time of climate crisis, one that could, instead of showing, that could sort of show in a new way the changes of the globe. After these lost 50 years, you could argue. Poole, as I said, so he wrote a book called Earthrise a few years ago that I also really recommend to some of you, even though he focused on Earthrise, which is an earlier planetary imagery. I might not agree with Robert, actually, because I do think that we have a continuous stream of blue marbles. This is just another example that NASA released in 2012. This is also a mosaic, and we should pay attention here. So what I was showing you just some time ago was the difference between, let me see if I can, well, maybe it's not that important. So these are mosaics taken by satellites. The blue marble was a photograph taken by a Hasselblad camera. So the technologies of getting these images are different, and even though we might not understand that as viewers. But I think there's a number of global images of this that we might, I'm not sure that a new one would give us that, but if so, I would be happy. I do think, though, that, and I'd like to also engage with this, the global vision. And one of my favorite papers is the one by Dennis Cosgrove, the geographer, before he wrote his Apollo's Eye book that maybe some of you have read, where he really does grapple with this kind of global vision, and also point to how it has different kinds of connotation. So he really thinks that it signifies a change from the one world imperialist idea in the late 60s to more of a whole Earth environmental conception. But I think time has passed, and there might be more to be said about this, and things are being said, obviously. I'm still very fascinated by the language of these large institutions that produce many of these images, right? Because you have the Eyes on the Earth, really large program, but you also have metaphors like witness, satellites as witnesses, right? So there's something going on here that I really that I'm fascinated and interested in. So obviously already now you understand that I'm really interested in how these are communicated. And if we just look at the lost sea ice, this is from the New York Times, and the Süddeutsche Zeitung had this one. And in both of these you can see actually that the sea routes are sort of alluded to. In the first one, the ship is really there. In the second one, we can sort of imagine that there's a route here. But there are also other ways of communicating sea ice. Here is one with that kind of, mammal that we've have associated with change. Sometimes I talk about the sea ice as the so if the polar bear is the iceberg, then maybe the sea ice is the phytoplankton of the climate change, right? It's not that kind of magnificent thing, but still. So let me continue. Birgit Schneider and Thomas Nock, who some of you might have known because they were here at the RCC some time ago, they've argued that there are two kinds of climate change imagery. They say that it's either the abstract condensates of global climate change, which we know through the Keeling curve, for example, right? So abstractations that build on an enormous amount of data. Or they think that they're the pictures of concrete climate events. And here, the calving iceberg that I just mentioned comes into mind, right? This we can see and it becomes an event. But what I am trying to argue then is that the images that we get from remote sensing satellites, they're actually condensates of global climate science. So here we have this image, which is not a picture, but it's an image that we can access. It's not an abstract image. But it still condensates and aggregates science in a different way than a photograph does. So here is a third version of climate change communication. And I'd like to try and wrap up this by ending with what I'm suggesting might be called the satellite sublime. So I am suggesting that these images could belong to the sublime. Or perhaps they are sublime, just as historic use of this term has changed. I've not really settled on whether or not the verb or the noun is doing the thing for me here, and I would love to talk to you about that. The sublime is a concept with a vast complexity and a really long history, and some suggest that it's been overused and lost its meaning. Others that it's best left for 18th century philosophy or 19th century aesthetics. The word itself is really tricky, and meanings have changed with language context, and over time it is to some extent untranslatable. And rightly so. It has an entry in the dictionary of the untranslatables. I will not delve into the differences between Burke and Kant, but I will instead suggest a 21st century sublime that can be used to describe and understand our relationship to climate change through planetary imagery. So following the philosopher Emily Brady, I believe that there is a case for historicizing the sublime, bridging different meanings over time. Brady argues that natural sublime can be restored as the environmental sublime, which could be a useful contemporary category. She does this by refuting several arguments that have been brought forward against the sublime. One is the historic argument that we are no longer amazed by nature. Another is the metaphysical argument that the sublime supposedly cannot go together with a secular understanding of the world. And finally, the anthropocentric argument that the sublime is really about ourselves. And she refutes all these three. Moreover, she does not really engage with the Anthropocene, which I think could be even more fruitful. So in 18th and 19th century writing, nature took position as a paradigmatic sublime. And that was partly a consequence of the possibility of experiencing natural places of sublimity, like mountains or waterfalls. In a book by David Nye in 1994, he introduced the technological sublime, which he argued was particular for the US, not having a cultural history to build on. So instead, Brooklyn Bridge, Hoover Dam, and Empire State Building became sublime in US consciousness. So the combination of high technology and climate change into complex representations of our anthropogenic environment, since that is the nexus of my interest, I think it might be useful to have an environmental sublime. It would furthermore merge what was earlier termed the nature sublime with the technological sublime. It would also allow me to acknowledge the interference of humankind and its resulting and the resulting new environment. Again, you could say environment. And the images, as I have alluded to and detailed to some extent, they are only possible through these large technological systems. Moreover, they are elevated, as I've indicated, and therefore also fit into this older version of the sublime, which demanded an uplifted position, like a mountain, for example. So the elevated and super complex technology is a prerequisite for the resulting images. They're at the core of my argument, but also contributes to the magnificence of the imagery. So just like the parts of the mosaic of CI's imagery that I have been talking about, I suggest that these pieces together might form a satellite sublime. Thank you for listening.